All right, so this is day 2 of our unit circle for anybody who's catching up. And every class started a little bit differently, but I think this is about where all of us were. I do know Alpha, if you're watching, you did not do the 45s, so I believe the other video has 45. So if you're in Alpha period, make sure that you watch all the way to the end of that, because I did all of these 45s with them. You guys are just a little bit behind. All right, since I'm sure you didn't spend your weekend thinking about the unit circle, which is okay, I didn't either. Let's review a couple things. So on all of these lines, we have angles in degrees, we have angles in radians, and then we have an ordered pair. I feel like at the very end of the class, I was telling you about how the ordered pair is the special part. That's kind of like what we've been working towards this whole time. The ordered pair tells me the sine and the cosine of every angle. So the whole point of the unit circle is I'm going to be able to say, like, hey, what's sine of 135 degrees? And you're going to be able to look at your unit circle. We will be able to go to whatever angle I said. I just said 135. And then sine is your y. So I would go to my y value there and say, okay, sine of 135 is equal to √2/2. I think we did this at the very end of class because Seth, you got your calculator out and you were trying to check me. And there's some like modes that need to be compared in order for us to get there. So your calculator might not be set up directly to do that. So you may just have to trust me for now. But that's the whole point of what we're doing. I'm going to argue that every angle on the circle are important angles that have a pattern here. And I'm also going to argue that while it looks like there's a ton of blanks, the numbers on the outside are just a combination of 5 different numbers. Okay, so it seems like there's a lot and you're gonna be like, oh, there's so much to learn. How am I gonna know how am I? It's gonna just start repeating. So like, you might just not believe me yet, but I promise soon it will make sense because you're like, oh, like I've seen this number over and over. It just starts like sticking in your head with certain pieces that it's supposed to go with. Okay, the one thing I do want to make sure, did we all write down the quadrants and then what the signs are for each quadrant? Do you guys all have that down? Because that's something important I do want you to write. So remember the top quadrant, top right quadrant is quadrant 1, and both the x and the y are positive. So that's what the positive comma positive means. Both the x and the y are positive. Quadrant 2 is the top left quadrant. Its x is always negative, but its y is always positive. As we did the 45, you saw that we carried that same like coordinate point all the way around. We just changed whether it was positive or negative. This little red part is reminding us whether it's positive or negative, whether the x or the y is positive, whether or not it's negative. So I just have that inside my shape. And once you have that down, we're going to do our 30, 60, 90 degrees. So we have, I don't know, 8 more lines to fill. Before I do that, let me actually talk about my bow tie angles, my reference angles. I didn't talk about this with my 45 because it truly didn't matter. 45 is the same distance from 0 to 45 as it is from 45 to 90. So all of the lines that I currently have, pink and yellow, they're all 45 degrees apart. It doesn't really matter which direction I'm going. It's all 45 degrees apart. However, now that I do 30 and 60, it is going to change a few things. Oh, I promise I'm okay. What'd you say? No, I already had that. The freshman gave it to me.
About COVID or Brogan?
COVID. I don't know what Brogan is. Do I want to know? Yeah, I don't think I want to know that today, but thank you. Reference angles are how all of our angles are going to be. So all of the pink ones are what we call reference 45-degree angles. So they were all like, we all use the concept of the 45, 45, 90 to draw those. When we do reference angles, they always, always, always come from the x-axis. So I'm going to draw like a little tiny axis right here. And when I draw an angle out, like if I'm drawing one in the first quadrant, my theta is close to the origin and my right angle touches the x-axis. Similarly, if I'm in the fourth quadrant, I'm just gonna go down. So if I was in the fourth quadrant, I would come down, I make my little right angle down there. My 90 degree is still touching the x-axis and my theta is still close to the origin. When I go to the second quadrant, I'm going to come up from my like 180 line. I'm going to come up from the negative x-axis and do the exact same thing. I don't need to draw theta in here anymore. I kind of know where he goes. And then in the third quadrant, same thing. I'm going to go down from the x-axis. In a triangle, I don't know what I was doing. The right angle is always on the x-axis. You will never, ever, ever, never draw it from the y-axis. So you will never have it look something like this. Never draw your right angle on the y-axis. That's just not how we do things. And I call these bow tie angles because that looks like a little bow tie, right? Perfect. All right, so our next angle we're going to do are 30. So my reference angle here, those are the lines that are closest to the x-axis. So I'm going to make them blue. So that's like this line right here, that's between 0 and 45. That would be 30 degrees away from the x-axis. Same thing in quadrant 4. I just am going 30 degrees below the x-axis. Similarly in quadrants 2 and 3, those are the lines closest to the x-axis, between like 180 and the pink lines and 0 and the pink lines. Okay. Let's go flip our paper over because we have to figure out what the 30-degree angles, sines, and cosines are in order to fill in more of this film. So the other day when we did our 45, 45, 90, we drew a little picture, we solved it all out. Similarly here, but I'm going to just tell you what all the side lengths are. So next to your 45, 45, 90 or somewhere on the back side of your paper, I want you to draw a 30, 60, 90, where the 30 is the one that's like on the ground, not the one like up in the air, the one that's on the ground, just like mine. And just like we did the other day, we're going to do sine of 30. And do cosine of 30. We're going to do tangent of 30. And then we're going to do all their reciprocal functions. Cosecant of 30. Secant of 30. And cotangent of 30. The reason I wrote 30 this time instead of just theta is because there's several different angles in here. On the other one, when it was 45 and 45, it truly didn't matter which angle you were looking from because it was going to give you the same answer. Now, though, we have to look from the 30-degree angle because it won't make sense if we don't look from that one. So when we have 30 as the angle that I'm like looking from, my opposite is the side across from 30. My adjacent is the side across from 60, and my hypotenuse, as always, is across from 90. At one time, I proved to you why what I'm about to say is true, but I just am not going to prove to you today. You're just going to have to trust me. The side across from 30, we're going to let that be 1. I'm going to let that be 1 unit. The hypotenuse in a 30, 60, 90 triangle is always 2 times whatever the side across from 30 is. So if the side across from 30 is 1, then the hypotenuse is 2. Which is how their relation works. And then the side across from 60 is a √3 times whatever the side across from 30 is. So that's like 1 √3 or just √3. That is just how the relation goes. I'm sorry, I don't have a better explanation, but it truly doesn't matter.
So it'll always be √3.
Always. Always, always. It will always be, always across from 30 is 1, always across from the hypotenuse is 2, and always across from 60 is √3.
If you can make me guarantees, it will be okay.
I guarantee always, always, always. And I don't get to say always a lot in math when I say it right now. Always.
Like here.
Okay, now let's actually do it. Let's do sine, cosine, tangent, all that fun stuff. If it's been a while since you've thought about it, remember that sine is opposite over hypotenuse. So that means in this case, it's 1/2. I'm gonna zoom out enough so you can see the picture, but I also can write kind of nicely. You don't have to write your O's, A's, and H's like I am right now. I'm just reminding you in case it's been a while since you've thought about it. Cosine is A/H, which in this case is going to be √3/2. And then tangent is O/A, which in this case is 1/√3. But as I told you last class, I really do want us to rationalize when we're in this part of the unit. So I want 1/√3 to be the same thing as √3/3. Bless you. Now that I have my sine, cosine, tangent, all of the functions next to them are the reciprocal of it. So I'm just going to flip it. So 1/2 is the same thing as 2/1, or just 2. 2/√3 is my secant, and I will rationalize that to be 2√3/3. And then my cotangent, I flip 1/radical 3. It's just radical 3. All right, just like we did the other day, the whole reason we did this is because now we're going to transfer the sine and the cosine over to my graph. Remember that cosine is your x, so my x for my 30-degree angles are all going to be √3/2, and sine is your y, so my y for all of these 30-degree reference angles is going to be 1/2. Okay, so let's do the very first one. We know that the one that's between 0 and 45 is just 30. It's just straight up 30. And let's actually write our coordinate points down before we forget it. My x is my cosine, which is √3/2, and my y is my sine, which is 1/2. Remember, the other blank is your radians, so I want to figure out what 30 is in radians. How do I go from degrees to radians? Pi/180. So 30 times pi/180. The zeros are going to cancel. 3 and 18 have a 3 in common, so it's pi/6. Okay. That means just like remember with our 45 degrees, all of them were something pi/4. All of my 30 degrees are going to be something pi/6. All right, shall we go to the second quadrant? Let's think about radians because my brain's already there right now. So when I was at 0, I went up pi/6 radians to get to 30. Okay, now I'm at pi, and I want to go backwards pi/6. You can think that I was at 1 pi, and I'm minusing 1 pi/6. How many pi's over 6 do I have now? 1 minus 1/6 is 5/6. Very good. 5 pi/6. The pi/6 that we found for the 30 a minute ago. We can do the same idea. We just did 1 pi minus 1 pi/6 to get my radians. Same idea for my degrees. If I have 180 and I'm minus 30, if I didn't quite go to 180, I went 30 less. How many degrees is that? 150. And then my ordered pair is the same as what it was before, but this time my x is negative. So it's going to be negative √3/2, comma, positive 1/2. Anybody questions yet? Okay, let's go to the next one. I'm already ready to do my ordered pair because I'm already thinking about it. It's still √3/2 over, and then 1/2, but they're both negative because I'm in the third quadrant. The other way I minus 30 because I was going backwards. I hadn't quite hit 180. Now I'm going a little bit past 180. I'm going 30 past 180. So what's my degree going to be here? I think I heard it 210. And then similarly with the radians. When I was at 180, I minus pi/6 or I minus 1/6. Now I'm at 180 and I need to go more than 1/6. So I'm going to go 1 plus 1/6. How many pi/6s do I have? 7. Very good. All right, one more. Now I'm going from the 180 side, or sorry, not the 180 side. I'm going from the 360 side. I was at 360 and I need to minus my 30 degrees. What's my degrees going to be here? 330. And I was at 2 pi, and now I'm minusing off pi/6. Again, if the pi's confused, you just think of it as 2 minus 1/6. What's 2 written as an improper fraction? 1/6. 12/6 minus 1/6, which is 11. It's going to be 11 pi/6, which is kind of weird.
Can you go back to the?
Let me write my ordered pair here and then I'll go back to the other side. The last thing I need to write here is my ordered pair. My x this time is positive and my y this time is negative. So it's positive √3/2 comma negative 1/2. I'll zoom out a little bit so you can see both sides. Remember the reason? Yeah, I just probably haven't graded it yet. I was doing other stuff. I'll try and get to it tonight. When you turn things in on time, it will be graded on time. It's my only promise. I have no other promises. Ethan?
Where did the 11 come from?
To get to 7 pi/6, I had 1 pi and I said plus 1 pi/6. So that's like 6 pi/6 plus 1 pi/6. And then to get my 11 pi/6, 2 pi is the same thing as 12 pi/6. So if I just get like denominators. You not charging? I've had a heck of a day with my iPad, guys. I mean, let me be clear. Did I charge it this weekend? Not at all. Did I come in this morning with 5% iPad battery? Absolutely. Did I expect it was going to work all day? I did. Did it? No. It died during my geometry class. It's not charging now.
Rain break, Tom.
Am I going to charge it tonight? I hope so. Who's to say?
I still need the one with the side of the circle.
Okay, I'll get it there. Are you okay with my 11 pi/6 though, Callie? We'll just let it be then. Do you want to? Do you need like the left side or do you need the top half? Okay. Can you see enough right here? Okay. Now you notice that we still have 4 more lines that we need to do. Those are my 60 degrees. We're gonna go back to the back side of our paper and we're gonna flip our triangle so that we're not focused on the 30 degree of my 30, 60, 90. We're gonna be focused on the 60 degree of my 30, 60, 90. Because these are all 60 degree reference angles.
What do the colors represent? I know it's like 45.
Good. The pinks are the 45s, the blues are the 30s, and the greens are the 60s. And then the yellows are just like the quadrant angles that are on the axes. once you have all of them in, you'll kind of see that there's like a common thing that happens with all the pink ones and all the green ones. So I just am color coding it now before you are like are ready to see the pattern, if that makes sense.
Is this something we would use on the test or quiz?
So you will not need it for the next quiz because I'm not ready to test you on this stuff yet. In the past, like, I feel like we had way more class time before pandemic stuff happened. I made them memorize this and I gave my class a quiz every day of 10 like sine, cosine, tan functions. And they just like, that's how we started class. And she just like did your 10. And they would like got to do the first week with the paper. And then after that, I said it had to be memorized. So my goal is for this to be memorized, but I also don't know how much time I have for this. What I would do is I would start like looking for patterns and like I will try and bring up as many patterns and see how much of you can start putting together and not needing this, but I have not told you it needs to be memorized yet. So, and that's a long answer, not really a clear one, but I hope that makes sense.
It makes sense.
Okay, good. Flip your paper over. Let's do our 60-degree paper, our 60-degree angle. Your sides are going to be the exact same as what they were before. So the side across from 30 is still 1. The side across from my 90 is still 2. And the side across from my 60 is √3. The only thing that changed though is my point of view. So instead of my point of view being 30 and my opposite being 1, my point of view is now 60. So my opposite is now √3. My hypotenuse is still 2, but my adjacent is not √3. My adjacent is 1. Once you have that, I want you to do sine, cosine, tangent. Oh, it's not here. That's why it's so quiet today. No, when you watch back on Zoom or on YouTube, we missed you. All right, I've set it up. Now I'm ready to put my actual ratios in.
Wait, that's the only thing I know how to do.
That's okay. A symbol for what? Okay. Sine, cosine, tangent is a super important part. So if you're like not still sure about what's happening with this unit circle, I promise it'll all start clicking. I just have to give you a ton of pieces that you don't know what to do with before we can put the puzzle together. But sine, cosine, tangent is so important and you should feel good if that feels good to you. You should feel proud of yourself for that. Once you've done all of your trig functions for your 60-degree triangle, we're going to take our sine, which is √3/2, and our cosine, which is 1/2, and put it on the first side for our x and y. Remind me, which one is our x? Cosine, good. And then that means sine is our y. So I'm going to do 1/2 comma √3/2. And that's like our next blank in our first quadrant. You will definitely have to do a table like this for the quiz, but it will be just like a random triangle here. No, it'll be something like this. I'll give you just like a random triangle and I'll say, okay, this side is 2, this side is √7. Here's your theta. Find this missing sign and do sine, cosine, tangent, cosecant, secant, cotangent. All right, let me bring this to the front side. Okay, so this is my 60-degree angle. My point is √3/2, comma 1/2. Nope, did I do that one wrong? Yep, I did do it wrong. 1/2 goes first. I don't know if any of you caught it, but when I was checking to see if I was right, I looked to see what my 30-degree was, and it's the opposite of that. Our 30-degree cosine is the same thing as the sine of your 60-degree and vice versa. So these points almost look the exact same. 1/2 √3/2, √3/2 and 1/2. If you look at this first quadrant, I only gave you 5 different numbers. I gave you 0, I gave you 1, I gave you 1/2, I gave you √3/2, and I gave you √2/2. If you look at all of the red numbers on this paper, they are all those 5 numbers, positive and negative. All of the coordinate points are just those 5 numbers, a different combination of them, and just positive or negative. The hardest part, I think, is the degrees, putting the degrees with that. But like the outside numbers are all the same things, just kind of rearranged in different signs. All right, let's figure out what my radian is for 60 before we move on. 60 times pi over 180. My zeros cancel, my 6 and my 18. Oh, they both have a 3 left. So pi over 3. If you notice, all my 30-degree reference angles had a pi over 6. All my 45s were pi over 4. All my 60s are going to be pi's over 3. So that's kind of a little shortcut I try and remember. The 4 and the 45 seem to make sense in my head, but I want my 6 to go with the pi over 6. I just have to remind myself I can't have both the 6's together. I have to have a 6 with a 3, and I have to have a 6 with a 3. So they just kind of mismatch with each other. All right, so let's go to the next one, quadrant 2. My coordinate point is the exact same as in quadrant 1, but my x is negative, so it goes negative 1/2 √3/2. It's a 60-degree reference angle, so I was at 180, and I'm minusing 60 from it. I didn't quite get to 180, I'm 60 degrees away, so what angle am I at? 120. And I was at 1 pi, and I'm minusing off 1 pi over 3. So what's 1 minus 1/3? 2/3. So it's going to be 2 pi over 3 is your radian there. You guys are getting the hang of these fractions. All right, my ordered pair is the exact same when I go down to quadrant 3. But it's both negative, negative 1/2, comma, negative √3/2. I'll zoom back out in a second. My angle is I hit 180 and I went 60 more degrees. What's 180 plus 60? 240. For some reason, I've done this for years, and 240 is always the one I have the hardest time with. There's going to be one number that you'll have the hardest time with. For me, it's 240. And I went to 180. And I added a pi over 3. 1 pi plus 1 pi over 3 is how many pi's over 3? Add. 1 plus 1/3. 1 pi plus 1 pi over 3. 4. Very good. 4 pi over 3. A little trick some people remember is that like in this third quadrant, see how all of the numerators are 1 more than the denominator. So 7 over 6, 5 over 4, 4 over 3. It's like a little hint some people use to help remember it. Just that quadrant. Quadrant 2, the numerator is 1 less than the denominator. So the denominator is 1 more. 2 over 3, 3 over 4, 5 over 6. The fourth one's just the weirdest quadrant. Let's do it in degrees first. If I was at 360 and I'm minusing off 60 degrees, what am I going to be at? 300. If I was at 2 and I minus off 1/3, how many thirds do I have? 5. So remember, this is like 2 over 1, so you got to make them have like denominators. 6 over 3 minus 1 over 3 is going to be 5 over 3. And my ordered pair is the same, except my y is the negative 1 this time. So positive 1/2, negative √3/2. Quadrant 1. All right, now that we have all the blanks filled in, we're gonna use this a little bit. I'm reminding you that I told you this, yes, or last class, but we haven't done anything with it yet. All of my X's are cosines and all of my sines are Y's. So again, if I were to say, okay, what's cosine of 240? We could go down to our 240 on our little lines. We're gonna go find 240. And I said cosine, right? Which one is cosine, your X or your Y? X. So I would say, okay, cosine of 240 is -1/2. That's why we're using this. So we can easily know some of these really important angles. I could say, okay, what's sine of 3 pi over 4? Well, I don't know what 3 pi over 4 is off the top of my head, but I know it's which reference angle. Is it a 30, 60, or 45? 3 pi over 4. 45, good. So I'm gonna go look at all my 45 lines until I find 3 pi over 4. Oh, it's right here. And I think I said sine, which is which, your X or your Y. Good. So sine of 3 pi over 4 is √2/2. So this is how we're using this tool. I want you to flip your paper over really quick while we're already on this paper to the basic trig functions. So I taught you the trig functions when we have a triangle and we're doing opposite, adjacent, hypotenuse. Now I just taught you how to use the circle and there's no opposite, adjacent, hypotenuses on there, right? All we have are X's and Y's. I just told you that your Y is your sine and your X is your cosine. If your sine is the same thing as Y, what's your cosecant going to be the same thing as? If 1/Y, those are all my reciprocal functions, so you flip it over. So if it was Y, it's now 1/Y. So I can find cosecant still by using my unit circle because I can just do 1 divided by whatever that Y is. Same thing for secant. If cosine is X, then secant is going to be 1/X. Now tan and cotangent are the hardest ones. Tangent is Y/X. And then so cotangent is the opposite of that, X/Y. They all kind of go together. And again, the dividing by fraction can kind of trip us up, but I'm going to argue that's an algebra skill, not a pre-cal skill. So that's something that like you maybe are not super familiar with or super comfortable with, but like you've done that before you came to my class. This is new, but you can divide fractions and we're going to do that in a second. I want you to keep that out and I want you to get your notes back out because we're going to get into our 4.2. We're going to do a few more problems with that today, okay? And the first thing we're doing includes my unit circle. Yes, you may. You can go to the bathroom. All right, so we left off on number 3. So we're going to do 3. I want to do 3, 4, and 5, but we will see what timing looks like. Okay. Just a reminder too, number 1 and 2 on the notes that we did a few days ago, that's like what Mikey was asking about, and those type of questions are fair game for the quiz. So number 1 and 2 on your 4.2 notes that we did before, that's fair game for your quiz. There will definitely be a problem like one of those on your quiz. Okay. Now, once we hit number 3, though, this is not fair game for your quiz yet because we're still practicing these. These say find the exact value, no calculator. So the minute it says no calculator, I'm thinking, okay, I want to use my unit circle. First one says sine of pi over 3. Okay, can you tell me what's pi over 3 in degrees? 60. And what's sine? Is that your X or your Y? Y. So can you go to your 60 line and tell me what your Y is?
2.
Perfect. That's it. I do want us to skip over and do letter D next because I think that's the easiest. So if you're on paper, just flip your paper over. If you're online, just scroll down. This one says cosine of pi over 3. What did you just tell me pi over 3 was the same thing as? Good, and cosine is what variable? X, so we're already at 60. What's your X value there? 1/2. Perfect. By just reading our picture, we already know what sine of pi over 3 is and cosine of pi over 3. Now, secant and tangent are going to be a little bit different because those are fractions. Let's actually do secant first. It says secant of pi over 4. What was pi over 4 in degrees again? 45, good. And secant is what in terms of x's and y's? 1 over x, very good, thank you, Haley. What's my x at 45? What's my x value at 45 degrees? Good, so we are essentially doing 1 divided by root 2 over 2. Now, my other classes all hated this too, but I would argue this is something you've seen before me. I'm also going to tell you that the rest of your math career, the hardest part is always algebra. Calculus, the hardest part, algebra. 3D calculus, the hardest part, algebra, not the calculus part. So when I'm going to do this, remember to get rid of this fraction inside a fraction, we're going to multiply by the reciprocal. So I've got 1 times root 2 over, or sorry, 1 times 2 over root 2. So that gives me 2 divided by root 2. And then I'm just going to rationalize and simplify. When I rationalize, I can't have a square root on top and bottom. So we multiply by root 2 on top and bottom to get 2 root 2 over 2. And then the 2's cancel. So my final answer is just root 2. Now, this is one of those things that I was kind of mentioning that like, I don't think you'll end up doing all of this math out over and over. I think you'll start remembering what some of these common answers are. Root 2 is going to be a common answer you will see. Ethan, do you have your hand up? I will not make you rationalize. You will not get points off if you do not rationalize tomorrow. All right, let's do tangent 2. Tangent of pi over 6. What degree is pi over 6? 30. And tangent is what in terms of x and y? Very good. So we're going to do a big fraction. We're going to do our y of our 30 degree divided by our x of our 30. What's your y for 30? 1/2. Good. So I'm going to do 1/2 divided by x, which is root 3 over 2. Everybody okay so far? Remember, when we have a fraction inside a fraction, we don't change the first one, but we instead of dividing, we multiply by the reciprocal. And that's actually really nice, right? Because my 2's are going to cancel. So I get 1 over root 3. And I told you with these special right triangles, we do want to rationalize. So let's multiply by root 3 on top and bottom, which is root 3 over 3. All right, anybody questions yet? All right, I still want to do numbers 4 and 5, but let's skip to do number 5 because that's a unit circle problem. Number 4 is a calculator, so I don't want to get our calculator yet until I'm done with my unit circle. All right, scroll down to number 5. This is actually doing essentially backwards of what we just did. This says sine of what degree, sine of what theta, sine of what angle is 1/2. For right now, for all intents and purposes, right now, we're only looking at quadrant 1. Okay, remind me, sine is which value? Y. So I want to know in quadrant 1, which angle has a y of 1/2? 30. And then what's its radian measure? Good. So sine of theta equals 1/2. Theta has to equal 30 or pi over 6. Okay, I'm gonna argue, let's do D next, because I think that's the next easiest. It says cosine of theta equals 1/2. Cosine is which variable again? X. So I'm gonna ask in quadrant 1, which X has a 1/2? 60. And what is the radian for that?
I would think.
5/3. So if my cosine of theta equals 1/2, then theta is 60 or pi/3. Those are the easy ones because we're just reading it, right? Is everybody doing okay? Say again. Uh-huh. The last two are a little bit different because we're dividing. Let's go do letter B. Let's do my secant first. So secant, what is that in terms of X and Y? 1/x. So I want my 1/x to equal √2. I'm going to argue that there's only one option here that will work. I told you that there was only 5 numbers that are in that quadrant 1, right? One of them 0. Will 1/0 ever equal √2? Nope. Another one's 1. Will 1/1 ever equal √2? Another one's 1/2. Will 1/1/2 equal √2? It could be, but it's missing one important thing. What does it not have that it would need in order to be √2? Not a negative. I think I heard it, a root. I would need it to be a square root, right? There's no radical on there, and there's no radical that's going to magically grow on it, right? It's just going to stay there. What if I had √3/2? Would 1 divided by √3/2 get us to √2? Nope. The only option that will work is √2/2. And I can prove it to you, but we just did that a minute ago. Scroll your little notes up to letter B of number 3. See how we did 1 divided by √2? 1 divided by 2, I still said that wrong. 1 divided by √2/2. I did all of that work right up here. And my answer was √2. So my secant can only happen when my X is √2/2. And what angle has my X be √2/2? What angle has my X that is √2/2? Good, 45. And what's its radian? Very good. The hardest part here is that I'm not really necessarily always doing a lot of math. Some of it's just reasoning. Do you understand my reasoning there so I didn't have to do a bunch of math? Yeah. All right, this next one though, we are gonna have to do a little bit of math in order to justify our reasoning. So this time tangent has to equal √3. My tangent is y/x, which means that I'm gonna have to do y divided by x in order, and I need to get √3 out of it. What is one of the options that's gonna get me there? What degree is one of the options that could get me there, do we think? 60 could work. What's another one that could work? 30. Why are those two options that I'm gonna check? Only one of them will work, but why are those options that are fair to check? Good. They both of them have √3/2 and 1/2. So the 2's are going to cancel and they have √3's in them. Okay, if I look at my 60 and my 30, does anyone have a best guess on which one's going to work? Or do I need to try them both? We can try them both. All right, so 60, what's your y for 60? √3/2, and then my x is my 1/2. Good. My 30 is the exact same thing, but it's opposite, 1/2 over √3/2. I can just do one more step and know which one's gonna work. If I do 1/2 and I multiply by the reciprocal, my √3 ends up in the denominator for my 30 degrees. Is that what I want? No. For my 60 degrees, when I multiply by the reciprocal, my 2's are gonna cancel and my √3 stays on top. So I actually don't have to do any more of 30 to know that it won't work. I found that my 60 degree works. So that means theta equals 60 degrees or pi over 3. In the next few days, we'll do a little bit more practice with this unit circle. Does anyone have any questions yet? Okay, I do want to do as much of number 4 as possible, and I do need to get your calculators out. Calculators, calculators, calculators. I'll get mine out too. All right, what I want you to do first is I want you to go to mode, and I want you to find the line that says radians and degrees. It might just say RAD and DEG, or it could spell it all the way out. And I want to do my degrees first. So if we're doing degrees, if I'm putting in degrees, I need my degree mode to be hit. So if you hit mode, I need your degree button to be the one that's lit up. Once you've done that, I want a second quit, second mode, get out of there. Okay.
You said do mode.
Mode, and then make sure your degree is lit up. All right, anytime that I've got a degree sign, I'm gonna do my degree mode. So A, B, and E are all degrees. All right, I have buttons that say sine, cosine, tangent. I do not have a button that says secant though, right? We know secant and cosine are reciprocal functions. So if I have secant, I can put 1 divided by cosine of 10, and that's gonna get me the same answer. So there's no secant button, but if I do second cosine, or not, sorry, not second, 1 divided by cosine, I did exactly what I don't want you to do. Don't do second. That's inverse, and we haven't done inverse functions yet. Cosine 10, and that gives me 1.0154. Round 4 places after the decimal when we do trig functions. Okay, anybody questions yet? Cosine is next to sine. It's like above the parentheses. All right, the next degree one I have says tan of 28 degrees, 11 minutes. Ooh, we gotta do an extra step here. Can we make 11 minutes into a decimal? How do I make 11 minutes into a decimal? I heard divide by 60. Perfect. 11 divided by 60 is 0.183. So I'm going to physically type in my calculator, tangent 28.183. And I don't have to do 1 over anything. I can just do straight up tangent. And that gives me 0.5358. You guys are doing great. All right, I'm going to jump over to letter E since I'm still in my degree mode. So I'm going to do all my degrees. We got to make 18 minutes into degrees. Even if you choose not to finish this with me, just don't disrupt everybody else. So 18 minutes is the same thing as 0.3, and then 13 seconds is going to be something a little bit crazier, I think. .00361. Add that plus 0.3. So that means what I'm physically putting into my calculator is going to be sine of 129.3036. $129.3036, and I get 0.7738. Yes, on the sign one we just did. All right, for sake of time, we'll do the radium ones next class. It's not hard, but I'm not gonna rush through it. And I've done a lot with you guys today, so. Remember, there's no homework, but there's a 5-question quiz tomorrow. Nothing we did, not tomorrow, next time I see you. Nothing we did today is on that quiz. We're done, I'm gonna stop recording.